Finding a point of intersection of two linear equations by substitution. So in the last video, I covered how to find the point of intersection with graphing. Graphing works well if the answer is a whole number and you've graphed your lines correctly. Yet graphing is pretty difficult if your answer is a fraction or a decimal. So we need a different method, and this method is substitution. The process in which you can solve a system of equations or finding the point of intersection of two lines with the substitution method is first to solve one of the equations for y, then substitute that result from step 1 into the other equation you haven't used for y. That should leave you an equation with only x's. So now you're going to solve for x, and once you have that answer for x, you can go back to the equation from step 1 and substitute that value of x in, which will give you the value for y. And that is your point of intersection. Okay, so the example that I have is I have two equations, 2x plus 3y equals 7 and x minus y equals 6. So two equations, and it's my choice for which of these equations I'm going to take and solve for y. You can see from my work in step I that I chose the second equation. I took x minus y equals 6 and solved it for y by subtracting the x from both sides of the equation and then dividing everything by -1, since there was a silent coefficient of -1 in front of y. I chose not to use the first equation for the reason that if I had tried to solve for y, I would have been dividing by 3, which would create fractions. And I really like to avoid fractions in the middle of my work. In step 2, I take that answer, y equals x minus 6, and I take that x minus 6 and substitute it into the other original equation where the letter y is. So we're going to keep the 2x plus 3, but where the y is, I'm now going to put x minus 6. Let me highlight that. And the equation had equaled 7, so I have equals 7. Okay. The equation only has the variable x in it now, so we can use the distributive property and add like terms and then solve the equation. So I get 2x plus 3x minus 18 equals 7. I have 5x minus 18 equals 7. And solve that equation by adding 18 to both sides of the equation. And lastly, divide by 5. So I get x equals 5. All right, this is one of the pieces of my answer, x equals 5. But I need to figure out the y value. The nice thing is I can go back up to step number 1, which was x minus 6, and that's what y equals. So y equals x minus 6, or 5 minus 6. And y equals -1. If I put these two pieces together, the fact that my x equals 5 and my y equals -1, put it into an ordered pair that tells me that the two lines, if they were to be graphed, would intersect at the point 5, -1. By doing it with algebra, I'm also finding out the ordered pair that makes both equations true. It's the only ordered pair that makes both equations true.